The BMW Z4, put through its paces by a professional driver on a closed course.
The Z4 Roadster is an absolutely incredible machine. The power delivery, the handling of the vehicle, phenomenal.
On closed courses and public streets, automotive journalists praise BMWs for their high performance, precision engineering, and fastidious quality. BMW makes sedans, coupes, and even SUVs. But the Z4 was introduced as a Roadster. A Roadster is an open-topped car with 2 seats, rear-wheel drive, and a long hood. A Roadster is designed to do one thing: give a driver the primal, exhilarating feel of the open road.
It should offer to the driver a real, authentic, puristic driving experience.
The Roadster Experience BMW style can cost you $45,000. It can't take a family of 4 anywhere or haul much cargo. But the Z4 has ways of making you forget about practicality.
You do not need such a car. You love it and you want to have it. Because to drive such a car is sheer driving pleasure. It's just fun.
Balanced, artful, the Z4 can seduce a potential owner with just one test drive. It happened to Ed Passon.
The dealer threw me the keys and said, take it for a ride. My first ride, it was incredible. The freedom, the sound, the air, the openness, along with the handling, you step on the gas and it just goes like there's nothing holding back. I was hooked.
When a customer orders a Z4 at the dealer, it sets in motion a series of factories which will build his car to order. It takes 3 Superfactories to build the Z4 Roadster, and each stage is marked by a cutting-edge blend of robot labor and the human touch. One factory builds the body. Another factory precision assembles the engine. And a third factory is here in Landshut, Germany, where BMW casts the engine crankcase. The crankcase is the heart of the engine. It houses the cylinders where violent explosions of fuel and air make pistons race up and down to power the engine. The Z4's crankcase begins as a liquid. Hot aluminum flows at 700 degrees Celsius. It's poured into a casting machine, which keeps it hot. Then, workers skim the oven surface to pull out any impurities and shut the oven door. Deep inside the casting machine, liquid aluminum is injected into a mold. 5 minutes later, the Z4's crankcase's rock-solid center, known as the insert, emerges. But that's just the beginning of this crankcase. Aluminum is a lightweight and strong metal, and that's why many high-performance crankcases are made entirely of aluminum. But BMW wanted an even lighter crankcase to help perfectly balance the Z4's weight over the front and rear axles. Perfect balance leads to agile handling. So how do you make a lighter crankcase? By using a lighter metal.
And BMW is first within the automotive industry to bring magnesium into a crankcase.
Magnesium is lighter than aluminum. But there's also a downside. Magnesium is weaker and is easily corroded by water. So BMW devised a crankcase with an aluminum center to handle most of the engine's moving parts and water cooling. Then they surrounded the center with magnesium. The result is a crankcase that's 24% lighter. It's strong where it needs to be and lightweight where it can be.
Here you see the 6-cylinder engine block with the insert and the magnesium surround. So the piston runs here in the cylinder lines. The water cooling runs also in the aluminum inserts. The oil cooling runs in the magnesium alloy.
But working with magnesium presents a serious problem. It's dangerous. Magnesium is harmless stacked in solid bars. But all that changes once robots pick up the bars and drop them into an oven. The magnesium is melted at 700 degrees Celsius. Now it's a fire hazard. Liquid magnesium erupts into flames when exposed to air. That's why liquid magnesium has to be moved in special airtight containers. All of the effort to handle the dangerous magnesium eventually pays off when it reaches the molding machine. Now, the magnesium casting process begins. First, the aluminum center of the crankcase is automatically fed to the machine. Robots load it into a massive 52 metric ton airtight mold. Then, a violent high-pressure injection. 26 kilograms of liquid magnesium shoots into the mold in 1/10 of a second. As the magnesium cools, it contracts around the aluminum center. 20 seconds later, a crankcase emerges, solid, but still piping hot. The foundry creates 2,000 of these crankcases every day.
With this product, we are the world champion. It's the lightest 6-cylinder inline crankcase of the world. It weighs about 30 kilograms and I easily can pick it up.
The finished crankcases are shipped 70 kilometers southwest to BMW's plant in the heart of Munich, Germany. BMW stands for Bavarian Motor Works, and this historic Bavarian city is where BMW got its start in 1916. The company began by making aircraft engines that push the performance envelope.
In 1919, BMW established a world altitude record, nearly 10 kilometers high, so that's the normal level of jets today. Imagine in an open aircraft, very cold, no oxygen, was really a big thing.
In the 1920s, BMW focused its innovation on the ground with motorcycles. Automobiles naturally followed in the early 1930s. The first BMW Roadster was the 3/15 PS in 1934. The BMW 328 hit the streets in 1936 and began winning races throughout Europe. In the mid-50s, BMW stunned auto enthusiasts with its next Roadster, the 507. Unfortunately, the car was expensive to produce and only 252 were made. But decades later, in 1996, BMW achieved mass-market Roadster success with the Z3. The Z4 replaced it in 2003. Today, BMW is still headquartered in Munich. Its modern towers are said to look like 4 engine cylinders. It's a fitting design because of what happens in the massive plant complex behind the office buildings.
We make more than 1,200 engines a day in Munich. 800 of them are 3.0 6-cylinder engines.
The 3.0 SI engine manufactured in Munich can launch the lightweight Z4 from 0 to 95 kilometers per hour in 5.6 seconds and take it to top speeds drivers can only estimate.
I don't know what the top speed of the BMW Z4 Roadster is because it's electronically limited to 155 miles an hour. I would think it would probably do about 165.
The 3.0 SI engine is an inline 6-cylinder design. Here's how it works. Valves let mists of air and fuel into the cylinders. Then spark plugs ignite explosions that move the pistons. They're connected to a crankshaft that converts the piston's downward motion to a circular motion. That circular motion moves through the transmission and turns a drive shaft. The drive shaft turns the rear differential. It turns the rear axle and spins the rear wheels. Engine power and performance starts when machined crankcases from the Landshut factory roll down the Munich assembly line. First, a robot selects a crankshaft and places it in the crankcase. Then the crankcase cover is bolted on. Machines flip the engine block for the next step, installing the pistons. Connector rods are dispensed to workers who attach them to the pistons. Then the pistons are installed and linked to the crankshaft. The cylinder head holds 24 valves. that will let gas and air into the cylinders and then let exhaust out. Plastic valve covers help keep engine weight down. Further down the line, plastic is used again, this time in the intake manifold. These parts can be plastic because they're outside the crankcase, away from the heat and explosions taking place inside. Almost 6 hours after the assembly began, the engine gets its final test, but not a drop of gasoline is used. It's known as a cold test, in which the engine is cranked with an external electric motor. Cold test checks the engine's mechanical operation, ignition system, electronics, and sensors. BMW believes the cold test is more thorough than firing up the engine with gasoline. After the cold test, associates attach the beginning of the exhaust system, the exhaust headers. Now, the engine is complete. The motor becomes one of 4,000 engines in BMW Munich's holding facility. Until it's shipped to its ultimate destination, BMW's Spartanburg factory.
This engine came from Munich, Germany. It's for order for the US, for the United States of America. It is a Z4 3.0 engine for a manual transmission.
BMW Spartanburg isn't in Germany. It's in Spartanburg County, South Carolina, USA. Every Z4 in the world, even ones on Bavarian country roads, was made in the American South. BMW Spartanburg and the more than 4,500 people who work here also build the X5 sport utility vehicle on the same assembly line. In an average workday, the plant builds 600 vehicles, 500 X5s, and 100 Z4s. When the factory opened in 1994, it was BMW's first full manufacturing plant outside German borders.
The barriers to enroll in a market are lower when you have local production. The US market is our biggest single market.
BMW Spartanburg divides production into 3 areas. The body shop, where raw steel is welded into Z4 bodies. The paint shop, where Z4s get their stunning finish. And assembly, where BMW associates flesh out the Z4 body with creature comforts. Now, the South Carolinians take the German engine and build the Z4's powertrain around it. The powertrain is the system that transfers the engine's power to the car's wheels. It starts with a 6-speed manual transmission. Then associates install hoses, wires, motor mounts, and electronics. A hoist carries the engine away. When the engine touches down, it's mounted to the front axle assembly. The rear axle assembly has a gearbox that will transmit power to the rear wheels. The drive shaft connects the gearbox to the engine and transmission. Rear shock absorbers will help cushion the Z4's firm ride. A short distance further, it's the end of the line for the powertrain assembly. It just has to get past an inspector with an eagle eye.
All right, I'm checking bolts, checking my steering knuckle bolt, make sure my bolt is paint marked. And I'm also going around here checking the broadcast sheet, looking at my hoses, make sure everything is flush for marriage. Making sure it's locked. Uh-oh, I have a defect. Motor mount bolt not tight. We'll flick it off and paint mark it. Okay. I'm going to go ahead and finish my inspection, make sure my shifter is straight, checking my drive shaft, support bearing, checking my springs, making sure it's level. That's good. It needs somebody to drive it. It's ready.
Just 40 minutes after the engine was unpacked from BMW Munich, The Z4's powertrain is complete. It'll eventually be joined with a Z4 body. The Z4's aggressively styled body takes shape in the body shop, where the Roadster's smooth lines begin as jagged stamped steel parts. It begins with the engine compartment. It's 1/3 of the chassis and will house the 3.0 six-cylinder motor. And the engine compartment begins with the dash bulkhead.
This is the dash bulkhead. The steering column goes here. This is the transmission tunnel. You have the left and the right steering gas pedal brackets that go here.
Once the dash bulkhead is loaded, robots take over and begin welding the engine compartment. With every weld, 8,000 amps of electricity heat the gun tips up to 500 degrees Celsius, enough to melt two pieces of metal together in a second. Each welding cycle requires massive amounts of hydraulic pressure to clamp down on the metal.
When it makes a cycle to make a weld, it closes together. And as it closes together, it has about 120 psi closing the caps together. If you were to stick your hand in there, then it would actually go through it. And if it was welding, then as it sent the electricity, it would get so hot it would sear your skin back together, so you wouldn't actually even bleed. You don't want that to happen.
The robots are always hungry for steel. They need human beings to feed them.
I am now going to get the wheelhouse and the spring cap. I'm going to grab the two brackets that's welded on it. And I will load them as so. Come out and mash my done button. Then I will load my carrier support. And I will grab a fender bracket and load them as so.
With workers safely behind closed doors, the robots snatch the pieces and spot weld them together. It takes just minutes for the robots to spot weld the Z4's engine compartment into a recognizable shape. The body shop has 480 robots who are usually dependable mechanical employees. But when one of the body shop's robots breaks down, production can stop for hours, costing BMW big money. The key is to spot robot problems early on, so they can be taken care of during scheduled maintenance. But how do you gauge a robot's health? By taking its temperature. When robots work, internal parts generate friction and heat. An abnormal increase in robot temperature could mean trouble.
Most failures will produce heat before the equipment actually fails.
The problem is, robot doctors can't get close to their patients while they work. The solution? A thermal imaging camera.
I can be 30 feet from this robot and determine the temperature without any kind of problem.
So, what's the diagnosis?
The picture I just took shows me that the hottest point on this robot is 94.5 degrees, which is not bad at all. That's a normal running temperature for this robot.
Ironically, that's just a few degrees cooler than the robot's flesh and blood counterparts. In all, the robots make more than 1,000 welds on the engine compartment. Then they pass it on to a human being who can reach spots robots can't.
As it comes out, I'm the first human to put the welds on. Make sure I weld my 11 welds in the correct spot. Add my 3 welds to this one. Get down in here and weld one of the spots that the robot can't get.
The human welds complete the engine compartment. The Z4's rear compartment features one of the Roadster's most distinctive elements.
We have the left and right hand roll bars. We're going to load them onto the bulkhead.
The Z4 has a low center of gravity. It helps keep it from flipping over during intense cornering. But if the worst happens, the roll bars will do more than just look cool.
They're important for the rollover. Keep the head protection, keep the car from coming down on them.
The roll bars are welded to the trunk bulkhead. Then, robots take over and build out the rear bulkhead assembly. For safety reasons, robots and people can't mix. That's why a special turnstile passes the assembly from robot to human. He welds the roll bars to the top of the assembly. During the process, a welder sometimes has thoughts no robot could ever have.
I think of it as if I were driving the car or my family were in the vehicle. Safety is the utmost importance.
BMW associates weld the rear wheel wells and add them to the bulkhead assembly. The rear compartment and engine compartment are done. They need the floor pan assembly to join them together. The floor pan, engine compartment, and rear compartment create the Z4's underbody, or chassis and frame. This metal platform is critical to the Z4's firm ride and precise handling.
The Z4's chassis is nice and stiff, just like you want a car like this. The car is very tight. You don't feel any flex in the vehicle, very rigid.
But right now, the chassis is still 3 loose pieces. They need to become one. And the way that happens is by welding. First, the chassis is flipped and attacked by a gang of robots. Then a team of 4 welders finishes the job. At times, they're separated only by a few millimeters of steel. They can sense what a welder on the other side is doing.
You feel the heat. After a while, you know when the other guy comes in. If he has a certain weld and you're right there, then you know just to hold off just for a minute, to go on in after he gets through with that, where the sparks doesn't come through the car to burn you, whether it be face, arm, or whatever.
It's critical that any defects in the chassis be spotted now, before the rest of the Z4 is built on top of it. First, the inspector tries to break the robot's spot welds with a hammer and chisel. If the welds survive, then they're good. Then he checks every part of the chassis for the slightest imperfection. The chassis is complete. The Z4's structural bones are in place. The body just needs the steel skin that gives the Roadster its distinctive lines. Fenders, trunk, and doors, which are lifted with a vacuum hoist. Now the entire surface of the car is carefully caressed.
I'm gloving the car down for defects, high spots, low spots on the surface so that we can fix them.
The remedy for high spots, low spots, or welding residue known as slag? Sanding.
This car has slag on it from the robots. So that's basically what I'm doing, is getting the sealer off of it. This is important because when it gets to paint, if we don't have it off here, then the paint don't stick properly to it.
The final body panel is the hood. It's made of aluminum instead of steel to keep the Z4's weight down. Just 6 hours after the Z4 began as raw metal, the body shop has welded, hammered, and gloved it into shape. Now it moves to the paint shop, where the Z4 will get its color. The paint shop is the factory's most power-hungry operation. Half of all power used by BMW Spartanburg is consumed here by a battalion of robots, conveyor systems, and 5 giant ovens that run up to 250 degrees Celsius. It's hard to believe, but most of the power that makes a Z4 look like this comes from rotting trash. 16 kilometers away, the 80-hectare Palmetto landfill captures methane gas from decomposing garbage and pipes it to BMW Spartanburg. At the landfill, the methane gas is harvested by more than 200 of these things poking up from the dirt.
This is a landfill methane extraction well.
This is used to draw the methane out of the landfill. The way this works is we have an 8-inch PVC pipe that's drilled down to within 15 feet of the bottom of the landfill. We have a vacuum that's applied through this 4-inch lateral line. The gas is sucked out through this piping.
Each well can extract methane within a 100-foot radius. The wells are evenly distributed to cover the whole landfill.
We have complete vacuum over the entire hill, capturing all the gas.
The captured methane gas is routed to a pipeline, which runs to BMW Spartanburg.
And when the gas gets here, our turbines burn that gas and create hot water and electricity for the use in the plant.
The methane gas gives the plant 63% of the power it needs to build and paint cars. The environmental benefits are significant.
By burning this gas here at our plant, we reduce the greenhouse gas emissions in the upstate of South Carolina by 60,000 tons per year, primarily CO2.
That's about the equivalent emissions of 4,300 cars driving around the equator every year. The power-hungry paint shop paints every Z4 to order after a customer like Ed Passon agonizes over one of 10 colors.
Color was the toughest decision, and I went around and around and around, asked friends. You know, I was getting opinions, and silver seemed to be the common color. I ended up with the Monaco blue, so I wanted something a little different.
Concealed beneath Monaco blue and the Z4's other colors is an 8-hour journey through the paint shop to ensure a flawless finish. All Z4s start out as a body in white, cold, naked steel. As the body enters the paint shop, it gets its first car wash. The wash degreases the cars and removes residues. Next, the Z4 body is dunked in what looks like a hot spring mineral water bath.
As you can see in here, this body's being submerged. It's completely submerged in the phosphate. It's extremely hot. As you can see, it's real foggy like a sauna in here.
The pool is 45 degrees Celsius. Minerals in the water form an acid bath of zinc, nickel, manganese, and phosphate.
Oh, trust me, you don't want to get down in there.
The phosphate bath will fight corrosion and help paint cling to the body's surface. When the cars emerge, their raw metal bodies are forever changed. Now the bodies move to the next step, the electrostatic coat, or E-coat. 190,000 liters of E-coat paint are electrically charged positive. The Z4 body is grounded by the carrier, giving it a negative charge. When the body is submerged, E-coat paint is magnetically attracted to every surface, crack, and crevice of the body. The result is a layer of paint that clings intensely to the body. The E-coat bond is so strong that excess paint can be washed off with water before the E-coat even dries. Then, the Z4 gets its first trip through an oven to dry the paint.
Right now you're looking at the outside of the E-coat oven. There's 5 zones in this oven. Temperatures reach all the way up to 400 degrees. The units stay in this oven for at least 30 minutes. We're gonna open up the door right here, let you peek inside, and look. We actually have a Z4 coming down the line right now, and you can see, here's the fender, here's the door. Extremely hot right here.
A half hour later, the Z4 cools down and is greeted by robots. Their job, spraying PVC or polyvinyl chloride. The PVC seals gaps in the body's metal and joints, making the car watertight. Now, the paint process gets serious. From this point forward, the Z4's elegant finish could be ruined by the tiniest hair or piece of lint. So if you work in BMW's paint shop, you wear a lint-free paint suit. Dust is also why these birds, ostriches, play a critical role in the paint shop. Ostrich feathers are efficient at gathering dust. That's why brushes with thousands of ostrich feathers give cars a final dusting before the bodies head into the primer booth. Robots begin the priming process by spraying the body's interior. Robots are programmed to paint faster, more consistently from vehicle to vehicle than human beings ever could. Then the car moves to another bay, where mists of electrostatically charged primer are magnetically attracted to the body's surface. The wet body is transferred to an oven for 30 minutes, where temperatures are carefully modulated between 150 and 250 degrees Celsius. A Z4 body will go through 5 ovens during its paint process. But there's one Z4 that's been through the ovens hundreds of times, and it shows.
This is our Z4 Oven Pro body. We use this to check our ovens inside our internal paint shop every month to make sure that we are following our specifications.
The car was originally E-coat gray, but it's not gray anymore.
The reason it's so brown is because this car has been through our ovens multiple times, and that's why it turns so brown and crispy.
The Oven Probe car has multiple temperature sensors on every part of the body, both on the surface and on the underside, to measure heat circulation.
There are 24 locations on a body that we check monthly to see if we're achieving the proper cure, if it's reaching the temperature it should reach, and the correct hold time in our ovens. This all transmits back to our transducer, which is inside these boxes.
The boxes shield the electronics inside from the oven's heat. With the data box secure, the Oven Probe body makes another journey into the oven. Its 24 sensors gather data. Hot spots will blister paint. Cool spots will prevent paint from drying properly. When the oven car emerges and cools, the data packs are removed and downloaded to a computer.
You have 6 sensors per pack. Each battery pack is collecting data on 6 different locations.
Then, the oven data is analyzed for anything that could damage the Z4's finish.
This temperature looks like it's within spec. If there's anything that's out of spec, what we will do is make adjustments to the ovens accordingly if necessary.
The Oven Probe car is sacrificed, so other Z4s can get a perfect finish. The next step for the primed body is the base coat, where the car gets its color. But first, another dusting by ostrich feathers. Then the robots color the car, in this case, blue. In all, the entire base coat consumes only 4 liters of paint. One reason why so little paint is needed is because so little paint is wasted. Like the primer coat, the base color coat is electrostatically charged and is attracted to the car's grounded surface. After a brief trip through the oven, the Z4 gets its final layer of paint, the clear coat, which gives the car its glossy sheen. The clear coat and all the layers of paint beneath it combine to add about 9 kilograms of weight to the Z4. The Z4's body is beautifully painted. Its engine and powertrain are waiting, but it's still a long way from being finished. The factory's assembly area is where the Z4 will be outfitted with ergonomic elements that will give an owner a great driving experience. The assembly area is also where it shows how much care BMW has put into the ergonomic experience of the people who build the Z4. You can see it the moment a car enters the assembly area and tilts on its side, so BMW associates can install fuel and brake lines and gas tanks.
This is what we call a tilt conveyor, and we actually turn the car on its side to facilitate ease of access to the underside of the car. We put the components on in a comfortable position rather than doing all the work overhead. When you do the work overhead, and you run a much higher risk of shoulder injuries and potential neck injuries, and we avoid those in this scenario by having the car put in front of the person.
Once the underbody of the car is built up, the carrier drops the body onto a conveyor belt. From this point on, the Z4 is just 8 hours away from being finished. Z4s that will later cruise the open road now cruise the assembly line, and they pick up their first passengers. The challenge is assembling a made-to-order car in which the customer has a say in nearly every option.
We're installing a firewall protector and sound definitioner for the Z4. The Z4s have 3 or 4 different types. It depends on what kind of sound you want to come up inside the car. You have thick ones and thin ones. A lot of people like the thin ones so you can hear the dual exhaust sound inside the car.
Next, the doors come off and are carried away. They're transported to a separate area where they can be assembled at an ergonomic height. Glass, mirrors, electronics, and door panels are all added and tested. Before the car goes any further, blue pads are added to protect the paint during the rest of the assembly process. Down the line, duffel bags packed with wires are put in an oven. It's all for a perfectly good ergonomic reason.
The wires are hot because it makes the wires more flexible to work with.
When the car is assembled, the wires will send power to the electronic systems. The wires will also light the famous BMW rondelle when the turn signal is activated. It's the first time the BMW logo is put on the Z4 body. Most auto enthusiasts believe the logo evokes BMW's past as an aircraft engine manufacturer.
For many years, even we at BMW told the public that this BMW logo is showing a rotating propeller. But we found out that this is not really true.
The truth behind the logo is much simpler. It points to BMW's Bavarian heritage.
The middle of the logo shows the colors of the Bavarian flags, white and blue, and this is the reason why BMW used it.
Today, the iconic logo connects the Z4 to BMW's legendary past. Further down the line, the dashboard goes in, and the steering column is tested. Then, the part that makes a convertible. In less than 2 minutes, a team of workers outfits the roll bars with covers, installs the center console, adds interior trim, and drops in a stereo that will compete with the throaty roar of the Z4's engine.
It's the Herman Kardon, and it's real clear. It is surround sound. It sounds real good.
While listening to that stereo, a driver needs something to sit in, something that can also cradle a driver as the Z4 clings to tight corners.
The seats in the Z4 are sculpted and they hold you in place so you can hit those corners at enough G's and still control the car.
But BMW doesn't make Z4 seats. They're made 8 kilometers away by Lear Corporation.
We produce approximately 260 seats a day for BMW. Any Z4 that's on the road today, those seats were made by Lear Corporation in this plant.
The challenge is not only to build a seat that will satisfy demanding Z4 drivers, but also to synchronize with BMW's production line. BMW tells Lear Corporation the style and color of the seat, along with which options, such as whether the seat is heated or is manually or automatically adjusted.
We get a signal from BMW as that car enters the paint shop. That's approximately 14 hours before that seat goes into the car.
From that point on, the seat production clock starts ticking. If the seat doesn't reach BMW in time, the Z4 assembly line gets held up. Even with the deadline pressure, the finished seats must be BMW quality.
Some guy could be going down the Autobahn going 150 miles an hour planted to this seat. Pretty neat thought.
It takes just a half hour to assemble a set of Z4 seats.
We get another signal from BMW as their car enters their assembly line. That's 6 hours before seat install, and that's when we ship the seats to BMW.
The seats arrive at BMW Spartanburg with just a few hours to spare. Then they're installed in the Z4. The question is whether the customer will properly adjust the seats once they get the car.
People have a tendency to sit too far away from the pedal controls and also the steering wheel. You want to adjust the seat forward so that when you press the brake pedal as hard as you possibly can, you have a slight bend in the knee. Okay, this is going to ensure you get maximum brake pressure. As far as the seat back goes, most people find it comfortable to sit with the seat laid way back like this and then find a nice, comfortable, relaxed position. This is not a good way to sit in the car. It doesn't offer you very good support, especially if you have to get into some pretty active driving. So we recommend that you bring the seat up to a comfortable but fairly vertical position, so when you press on the pedal, you go into the seat, you don't slide up the seat. And the way you kind of fine-tune this is with the steering wheel. You're gonna put your back against the seat, extend the arms to the 12 o'clock position, and your wrist should break right over the top of the wheel. That's gonna give you a good baseline starting position.
The installation of the seats and most of the Z4 assembly process is done by hand. But there is one item delegated to a robot, the windshield. It begins by putting a powerful adhesive on the glass. Then it installs the windshield. Human beings inspect the robot's work, checking tolerances.
The robot did a good job putting it in.
While looking out the windshield, a driver needs something to hang on to. That's where the steering wheel comes in, even if some steering wheels seem to be put in on the wrong side.
Nothing wrong with the car. Steering wheel's on the right side because it's going overseas.
And then, in a few seconds, a BMW associate installs something that could save a driver's life.
I'm putting in the driver's airbag.
Further down the line, the doors that were assembled offline are put back on the vehicle. The windows and convertible top are tested to make sure they work flawlessly. If the car checks out, it's sent down the line for one of the biggest steps on the floor, joining its powertrain. The final stages begin with a moment so serious that those on the floor call it a marriage. A wedding of the body and the powertrain. It's a quick ceremony, presided over by machines and finished in seconds. Next, BMW associates complete the linkages, including connecting the powertrain shock absorbers to the engine compartment. Now, an overhead hoist system carries the car through the next stages, including the exhaust system installation. The problem is the exhaust system weighs over 20 kilograms. Lifting that kind of weight overhead on a moving production line hundreds of times a day would take a major ergonomic toll on the technicians. The solution? A hovercraft that does the lifting for them. It glides on the surface floor as the vehicle moves on the assembly line.
They're simultaneously installing it to the rear and to the front of the vehicle. Nicole is installing it to the front as Bill and Kevin are installing it to the rear.
The hovercraft glides on a cushion of air, only a few millimeters above the floor, effortlessly moving with the assembly line.
And now when they're through with it, they'll hit the release switch, they'll push it out of the way, and it will go into the retraction mode.
The Z4 is nearing the end of the manufacturing process. But from the front, the car doesn't quite look like a BMW yet. It needs the famous double-kidney grille.
It started with the original BMW, the 303 in 1933. But during that time, it was just necessity for construction, for air cooling.
But the distinctive radiator grille soon became a signature design element. It's graced nearly every BMW model that followed.
Today, the double kidney grille shows the people directly, this is a BMW. From the first view, you can see that's a BMW.
Nobody will see the Z4 and its double kidney grille coming unless it has wheels and tires. And now, the Z4 can stand on its own for the first time. While the line moves, BMW associates put 20 liters of fuel in the tank. Then they fill the rest of the fluids in under 4 minutes. The assembly process is finished, and now the protective pads come off. The Z4 is ready for its first test drive. But it won't be on the road. It'll be in a roll booth. A driver reaches speeds of 160 kilometers per hour and goes nowhere while he does it.
Feels great to drive 100 miles an hour inside the roll booth. I mean, it feels like you're on a cloud and just rolling through the wind. Awesome feeling.
The final inspection demands BMW associates comb through the car one final time, checking their work for the slightest defects and fixing them the rare time something's not right. It's taken about 40 hours of build and paint time for the Z4 to go from raw bits of steel to a gleaming high-performance roadster. But the Z4 still isn't done. It needs one final item. The Z4 badge. Now the car is complete and ready to ship. Some Z4 buyers traveled to BMW Spartanburg to pick up their Z4s directly from the factory.
My wife and I flew here from Denver and are going to be driving the car back. But I've been excited for months about this and been waiting and it's finally here.
But sometimes picking up your dream car doesn't work out the way you thought it would.
I was playing soccer and I tore a tendon in my foot. More painful than the injury is not being able to drive the car home. My wife has graciously offered to drive the car home.
At the end of their shifts, those who build the Z4 Roadster in Spartanburg County, South Carolina, leave with the pride of knowing they've built a car that delivers on BMW's reputation for quality, even though their factory is an ocean away from BMW's Bavarian roots. To build the ultimate roadster, it takes 3 Superfactories, the factories behind the Z4. BMW Landshut, BMW Munich, and BMW Spartanburg. They're all Superfactories.